So in this question, we want to know what the molar mass is of this unknown diprotic acid. And what a diprotic acid is, it's an acid that's going to release two H plus ions in solution. And so we have the grams here, and then we have this volume in here that we're going to fill up with this volumetric flask. And what we're going to do is we're going to take some of this, this volume in here, and we're going to react it with this, this concentration of NaOH, and we're going to add 26.1 milliliters of the NaOH solution. And this 26.1 milliliters, that's the amount that's going to be required to reach the equivalence point. And at the equivalence point, the amount of H plus and the amount of OH are equal in terms of their moles. And so what we can do is we can make a picture for what's going on in this problem. And so what I'm going to do is I'm going to draw a flask down here. And in this flask, this is where I'm going to put the unknown diprotic acid. And so here's my flask in here. And I'm going to color code this. So I'll do this right here in this pink. And so here is going to be my diprotic acid, my unknown diprotic acid. And so this right here is going to be the 0.262 grams that I'm going to put in here. So I'm going to take 0.262 grams, and that's going to go into that flask. And it's also going to put in there 250 milliliters goes in there. So we're going to do 250 milliliters, and that's going to be of water. So that goes in there. And because we don't know the molar mass of this, we don't know how many moles we're putting in there. And so the moles in here, we do not know. And we know that we have this NaOH that we're going to put in here. And so that's going to go into this burette like this. And so here's my burette. And what a burette is, it's basically a tool that we're going to use to figure out how much volume we're going to add of the base in here to go into this diprotic acid in here. And so, like I said, I'm going to color code these. So I'm going to do this right here in this blue. And so this is going to be my NaOH, and that's going to be the 0.15 molarity NaOH, and we're going to add 26.1 milliliters of that. And so we know the molarity in here. The molarity is going to be 0.15, and the volume that we're going to add to that is going to be this 26.1 milliliters. And so what I'm going to do is, when this goes in here and then reacts in here, there's going to be a reaction, and that reaction is going to be a neutralization reaction in which the H plus and the OH are going to basically cancel each other out to make water. And so there's basically three different reactions that we're going to have for this question. In the first reaction, we're going to have the NaOH. So I'm going to put NaOH, and it's going to make OH minus ions. And so what I'm going to do is I'm going to put the Na here, Na plus, and then I'm going to have the OH minus in here. And to figure out how this thing splits apart is you can do this trick where I do the second capital letter and I put a line down here, and this right here will be the positive part, and this right here will be the negative part. And so I have one of these NAs right here, so I have just one Na, and the charge comes from this this OH right here. I have just one of those, and so I would bring that one up there. That's where I get the +1 right in there. And I have one Na, and if I bring that one up here, I'm going to get this -1 right there. And so if I have 0.15 molarity of this, and I have 26.1 milliliters of this, I can find how many moles of this I have. And that's because the number of moles given a molarity is going to be equal to number of moles divided by the volume. And so if I take the molarity times the volume in liters, I'm going to get the number of moles in here. And so I'll do these two numbers multiplied by each other, and make sure you convert this one right here to liters by dividing by 1,000, and you're going to get 0.03915, and that's going to be moles of NaOH. And so I'm going to go from the NaOH right here to the OH minus right in there. And so what I'm going to do is I'm going to take this number right here and put it over 1, and then I'm going to use the balanced chemical reaction that I put up here and say I have NaOH. It goes on the bottom, and I'm going to put the OH minus up top, and there's a 1 right here, so I want to put a 1 right here, and there's a 1 right here, so I'm going to put a 1 right here. And the reason why this NaOH went on the bottom is so that this and this can cancel out, and then when I go to take this number here times 1 divided by 1, I'm going to get 0.003915, and that will be moles of OH minus. And so now that I know the number of moles of OH minus, it's going to be that number of OH that's going to go ahead and react with the H plus down here. And so what I'm going to do is I'm going to say that I have H plus OH minus, and that's going to go ahead and make H2O. And this occurs at the equivalence point right here. And so if I know that I've got this 0.003915 moles of this OH right here, that's going to be the number of moles of this H plus right here that I'm going to have to neutralize all of this and to make H2O. And so this number right here is going to be 0.003915 moles of this H plus right there. And so what I'm going to do now is I'm going to do my third reaction, and for the third reaction, it's an unknown diprotic acid, and diprotic, that's going to mean I got 2 H pluses. That's going to be made in solution. So I'm going to go ahead and write down that I've got H2X right here, and the second capital letter is where it's going to split at, and I'm going to get 2H plus X 2 minus, and that's because this 2 right here came up there, and that's how I got the 2 minus there, and I have 1X here, and so that's going to go up there, and that's how I got this plus right there. And so again, the second capital letter is where it splits, just like it split right in here. And so I'm going to have 0.003915 moles of this, and I need to go to this one because this is what I'm trying to figure out. This is my unknown diprotic acid in here, and I need to get the molar mass of this. So what I'm going to do is I'm going to do something similar like I did up here. I'm going to take this 0.003915, and that's going to be moles of H plus, and I'll put that over 1 like this, and I'm going to go to the H2X, so that's going to go up top, and I'll put the H plus on the bottom, and then from the balanced chemical reaction there's a 2 right there, so let's go ahead and put a 2 there, and then there's a 1 right there, and so I'm going to put a 1 right there. So when I take this number here times 1 and divide it by 2, I'm going to get 0.001975, and that will be moles of H2X. And so this is number of moles of H2X that I'm going to have, and I need the molar mass. So I have the amount in grams, which is up here, and I know the number of moles. So if I have the number of moles, that's going to be equal to the amount in grams divided by the molar mass. And so I'm going to do this equation right here for this and this right here. And so I know that I'm going to get 0.001975, and that's going to be equal to the amount in grams. That's going to be this 0.262, and divide that by the molar mass. And so when I solve this equation right here for the molar mass, I want to get that the molar mass is going to be equal to 134. And so the molar mass of this unknown diprotic acid is going to be 134 grams per mole.